So we're going to look at fractions of amounts, and we're going to look at finding fractions of amounts of numbers and of shapes. This video is one of a series of videos that I have done on fractions. The key one probably to focus on that will help you here is about equivalent fractions, but it would be advisable to try and do some of the other videos as well to get an overall picture of fractions. If I wanted to show 3/4, we could draw it like this. So I have a rectangle. I divide the rectangle into 4 equal pieces, and then we shade in 3 of them, and that is 3/4. And so the process for finding 3/4 of something is you divide that something into 4 equal parts, and then you multiply it by 3. And we can apply this to an amount. So if we were finding 3/4 of 12, we would do 12 divided by 4, which is equal to 3, and then 3 multiplied by 3, which is equal to 9. And if we were doing it in a calculator, we would type in 12 divided by 4 multiplied by 3 is equal to 9. You could, of course, have done 12 multiplied by 3 divided by 4 and got the same answer. Let's look at the relationship between the original amount, the answer, and the fraction we are using. Notice that if I write a fraction where the numerator is the answer, which in this case is 9, and the denominator is the number we originally started with, which is 12, we end up with a fraction 9/12. And notice that this is an equivalent fraction to 3/4 if we were to divide top and bottom by 3. We can also say that 9 is 3/4 of 12, or we could say that 12 is 4/3 of 9. Notice that in the second statement we have the reciprocal of 3/4, which is 4/3. Find 3/5 of £60. So we're going to do 60 divided by 5, and then multiply that answer by 3. Well, 60 divided by 5 is equal to 12. Now we do 12 multiplied by 3 is equal to 36. If this was in a calculator paper, you would type in 60 divided by 5 multiplied by 3, and you then get the answer 36. Again, let's look at the relationship between the number we started with, the answer, and the fraction that we used. So writing a fraction with the answer as the numerator, which is 36, and the denominator of 60, which is the amount we started with, we end up with 36/60. And this is an equivalent fraction to 3/5. If we divide top and bottom by 12, we can see this. We can also say that £36 is 3/5 of £60, or that £60 is 5/3 of £36, where 5/3 is the reciprocal of 3/5. And finally, find 7/20 of £360. Well, without a calculator, I would be doing £360 divided by 20. I can divide through by 10. And then I've got 36/2. Well, 36 divided by 2 is equal to 18. 18 multiplied by 7. Well, 10 multiplied by 7 is 70. Add 8 sevens, which is 56. So that is equal to 126. And if I was doing this on a calculator, I'd type in 360 divided by 20 multiplied by 7, and that would give me the answer 126. And if I make a fraction of the answer over the original amount, so that's 126/360, well, this is an equivalent fraction to 7/20, which I get by dividing top and bottom by 18. I can also say that £126 is 7/20 of £360, or that £360 is 27ths of £126. The reason I want you to look at the relationship between the original amount, the answer, and the fraction is just to offer further thinking about fractions of amounts. But I'm not going to go into too much detail beyond what I've done here. But let's move on. Here's a pizza, and hopefully you can make out the slices. There are 10 of them. What fraction of the pizza is each slice? Now, if you think the answer is 1/10, unfortunately you are wrong. Why is that? Well, let's look at the slices in more detail. I'll mark out the pizza and the slices more clearly. Now, if I had first dibs on choosing a slice, I would probably go for this slice here because it's the biggest, or maybe this one down here. But we can see that each slice is not the same size, which must mean that each slice isn't 1/10. Also, there's the circumference of the pizza, which is also not a perfect circle, regardless of the graphics overlay we have here. Because the slices are not the same size, each slice is not 1/10. The reason I wanted to look at this is because some students do get caught up on what we mean by a fraction of an amount when dealing with drawings. Pizzas aren't usually sliced into equal sized slices, and yet pizzas are often used to demonstrate what is meant by a fraction. And maybe this might bring about some confusion as to what is meant by a fraction of an amount. For example, if I have this shape here, what fraction of the shape has been shaded? Now, some students might say 1/4 because the square has been divided into 4 parts and one of those parts is shaded. But we can also see that each part is not the same size. So the shaded part is not 1/4. So I wonder whether some students, because of dealing with pizzas when they first get introduced to fractions, might not think that each piece of the shape or each piece of the pizza has to be exactly the same size, because pizzas in the real world aren't cut into equal size slices. This, of course, can lead on to other issues, such as if a student is being asked to draw a fraction of an amount, they will often use circles which are not easy to divide. What if you wanted to have to show 5/7 of something as a drawing? Is using a circle a good idea? It might be more advisable to use squared paper. Maybe draw a shape made up of 7 squares and then shade in 5 of them. But let's look at some shapes where part of them have been shaded in. In this first shape, a rectangle, we can see that there are 24 squares, and each square is exactly the same size. 12 of those squares have been shaded in. So we have 12 out of 24. Now, because we've been doing work on equivalent fractions, 12 over 24 can be simplified to 1/2 by dividing top and bottom by 12. Now let's look at this shape. We have a triangle that has been divided into 9 equal triangles, and 6 of them have been shaded in. So we've got 6/9, and that of course can be simplified to 2/3 by dividing top and bottom by 3. And of course we have a circle here which is 1/4 because the circle's been divided into 4 equal parts and one of them has been shaded in. Looking at some more challenging shapes, here we have a hexagon and an area has been shaded in. So what fraction of the hexagon is the shaded area? The simplest way to tackle this problem is to try and divide the shape up into equal parts and use that to help us determine the size or the area of the shaded bit as a fraction of the whole shape. If I was to draw a dotted line along here, and along here, and along here, we have divided the hexagon into 6 equal parts. They all happen to be triangles. 2 of those parts, 2 of those triangles, have been shaded in. So actually the fraction of the hexagon is 2 over 6. And this, of course, can be simplified to 1/3. With the next shape, which is a square, what we can do is divide that square up into 8 equal parts by drawing dotted lines as shown here. One of those has been shaded in, so we end up with 1/8. And finally, with this shape here, again, it's another square. If I was to divide this square up into 8s, we can see that this bit down here can go into this bit up here. And so we end up with shading in 4/8, which of course simplifies to a half. And we can easily see that that shaded area is actually a half of the square. And finally, I want to have a look at some shapes where you may be required to shade in the required amount. So we have a rectangle here which has been divided into equal parts, and you've got to shade in 5/6. Well, if we count the number of equal parts, we see that we have got 12 of them. That means that 5/6 is equal to something over 12. Well, that something must equal 10. If we multiply both top and bottom by 2, we end up with 10/12. So we need to shade in 10 of those squares, and that will give us 5/6 of the original shape. In the next shape, we need to find 2/5. The shape has been divided up into 10 equal pieces, and we need to find 2/5. So writing 2/5 as something over 10, well, 5 multiplied by 2 is equal to 10. So if I multiply the denominator by 2, I have to multiply the numerator by 2. So 2/5 is the same as 4/10. So I shade in 4 of those triangles. It doesn't matter which triangles you shade in, as long as you just shade in 4 of them. And finally, we have this square here, and we need to find 3/8. The square hasn't been divided into 8 equal parts, which is what we need to do, because we need to divide that square into 8 equal parts and shade in 3 of those parts. Let's finish off by dividing the square up into 8 equal parts by putting some dotted lines here and here. We now have 8 equal parts, and we shade in 3 of those parts, and there we have 3/8. So there's a brief look at fractions of amounts. It is important to remember, especially when dealing with shapes, that the parts of the shapes need to be the same, as shown here. These squares are all the same size. These triangles are all the same size. And then when we did this problem here, we had to create 8 triangles all of the same size. Also, if you get asked to show a fraction as a drawing, my advice is to use squared paper. So remember, when we looked at drawing 5/7 as an example, draw a shape using 7 squares and then shade in 5 of them. In the next video, I'm going to be looking at percentages, and this is a continuation of some of the work we were doing in this video. But this time with percentages, we are finding fractions of amounts where the fraction is something over 100. Remember that percentage means out of 100. But I hope you found the video helpful, and thank you for watching.